Hello, everyone. I want to ask a simple question, and that is why SQL or SQL? Well, to kind of give a better understanding of it, let's talk a little bit of the history. Databases existed before structured query languages were even conceived in the 1970s by IBM researchers. Often it took many hours to write programs in languages like COBOL to generate queries or reports. Even when SQL database software was available in the early 80s, it was often expensive and it took a lot of RAM, which was also very expensive. So you could imagine that a small business may take a CSV file, common separated value, with a bunch of data in it, and use a programming language to write, to get a report out of it, something like a language like BASIC. So to kind of give you guys a little bit of background, I want to get a period correct computer, and I'm going to show you on my Sanyo how this works. And on my Sanyo computer from 1983, you can see it's got disk drives and everything else. I've recently modified it so it has what's called a GoTech, so I can easily load software in it. But you'll see in a moment how that works. So I'm going to actually just give you a feel of the time period by loading up MS-DOS on my Sanyo computer. And you would go into DOS. And let me view the CSV file, and you can see it's really slow. Now, excuse me for the choppiness, but this is just me trying to stabilize the camera. But you can see there's a lot of data out there that has to be read out, so you have to program it. So I'm going to clear the screen, go into BASIC. Now I'm going to actually switch over to a emulated version of BASIC to kind of give you an idea of how this works. Now I'm going to load up a program that I already wrote called World Data. And I'm going to list the program. Now this is a very simple program, but you can see right away, in order to get the actual data that you need out of this file here called worlddata.csv, you have to write quite a bit of code. I have to actually print out the columns like country, year, M for month, and temp for the temperature. I have to like hand print that output. On line 30, I'm going to open the file up. That's the world data CSV file. So that's a comma separated file. On line 40, I have to actually input in the different values. So later on it could be outputted. And then on line 50, I have to actually check each one of these. So the C $ is a string for the country code. The Y string variable is for the year. The M string value and the $ represents a string. That would be for the month. And the T string that we're going to get out of the CSV file is for the temperature. And then on line 50, you can see I'm basically doing a series of if statements. If the country is the United States, then if the year is 1990, then if the value of the month, because now I have to take the string of the month and convert it to a numeric value and do lesser than 7. So I'm going to get just the first 6 months out of the year 1990 and for the country of the United States. And then at the very end, I'm going to print out the country, the year, the month, and the temperature for each row of data. And then it's going to loop back up to line 40. So it's just basically a giant loop that's looping around this code for each record. And then in the very end, I'm going to print another line so it's a little bit easier to read. I'm going to close number 1, which is the file, So I'm going to close this file and I'm going to end the program. On line 7, I have to basically handle any error. This is not the best way to do it, but in order to just kind of show you so it doesn't throw an error at the end, I'll just go to line 75, which will then end the program. And then of course line 5 is to clear the screen. So when I run this program, it prints it out. Now I'm on an emulated version. I'm on my Mac right now. So this program ran very quickly. On the original computer, it would have ran a lot slower. Now if we switch over to MySQL, which is a modern version of SQL, or SQL for someone who doesn't know what SQL is, which is just basically structured English query language, we have a database set up called World Data over here. And basically I have a table called World Temperatures. And in that table, it's got a bunch of fields, like the temp ID, which is unique primary key, the calendar year, the month number, the country code, and the monthly temperature. Now, in order to do the same query, you could see I'm just going to do these 3 lines of code. This right here is using the World Data database down here. So when I run this, it runs it nice and quickly. So you can see in a very simple comparison, if I'm going to use just one table in SQL versus writing a program in BASIC, I mean, BASIC is still more complicated and slow. But what happens if I want to, for example, say I don't want to show the month number or the country code. I want to actually show the name. So I want to show United States of America and the month, like January, February, March, April, May, and June. Well, if I were to do that in BASIC, I would have to take the program and I would have to either have another file that you could look up to compare USA to United States of America, then look up for the month ID and convert it 1 to January, 2 for February. I'd have to write a series of if statements in here to actually be able to do that. And so it would be quite complicated to do. Well, in SQL, you have tables out here. So I have 2 other tables, and this is the relational part of SQL. So there is a table that's got the country codes. So if I go to the bottom, you'll see that there is actually country codes for them. And United States of America. So I have United States of America. I can actually interjoin this table onto the query that I have here. The same with the month name. You could do a quick query on it. You could see 1 is January, 2 is February. So I can come into this query and I can say from the world temperatures, interjoin, and I could do the table, country names, and I'm going to actually give it an alias to make it easier. I'm going to call this C on, and my world temperatures here now, I'm going to just call it temps, and I'm going to say on C, and I'm going to do country code equals temps country code. So I'm going to interjoin those 2. And I'm going to interjoin the month names, which I will call it M. This is an alias, so I'm going to give it like an abbreviation, kind of like a nickname. And I'm going to do month names equals temps. Actually, the month names here would be, if I look at my columns here, would be month number. So I'm going to change that to month number, and that would be our temp month number. So I'm basically interjoining those two. At this point, I could change country name here, and I could change it to what its corresponding field would be, country code, country name. So I could call this country name, and this right here I could call month name, because that would be its corresponding field. Country code would be the primary key, and country names there, so that is that. And the month number there would be the month name in the month table. So I'm basically interjoining these three tables together. So now at this point when I run it, I get an error, but I can quickly fix it because the country code is in two different tables, country names and in world temperature. So I'm going to tell it which one. In this case, it doesn't matter. I'm going to say out of the temperatures, monthly temperatures table, and also the month number. I'm going to do that one as well. And now when I run it, you can see it now gives me the result, which has the country name, the full name, and the month name out of it. So I quickly interjoined all these tables together, and that's the power of SQL. It's a relational database. You can break things out into tables and quickly query them, where in a previous time you would have to actually write a program to basically pull in different information in a long program with a series of if statements, or even if you're using arrays, it would still be quite tedious and it'd be quite complicated to do. And so that's why SQL is so powerful. And you really couldn't have the World Wide Web like you know it today without it, because it was a pivotal part of collecting and actually retrieving data.